Okay, guys, we're going to talk about something super simple, super easy concept. The questions on your end of course about this are super easy, so I would feel horrible if I didn't get to this, mention it in class just a little bit, let you watch this video to explain it. So it's just talking about acids and bases and pH. And the first and foremost thing you need to be able to do is describe the properties of acids. And if you're given a list of formulas, they're going to ask you which of the following could be an acid. And it's just based on what the acids and bases do in terms of reactions. So acids always contain what we call hydrogen ions. All right, so in the formula for an acid, you're going to see hydrogen in the beginning of that acid formula. So notice all of these acids formulas that I've written. This is hydrochloric acid. There's an H in the front. Sulfuric acid, H in the front. Phosphoric acid, nitric acid, acetic acid, they all begin with H. Their formulas always begin with H. So given a list of formulas and asked on the end of course test, which of the following could be an acid, you're going to look for the one with an H in the front. Same alternative, given bases. Bases produce what we call hydroxide ions. So typically you're going to see an OH in the formula. Okay, with the exception of this one, don't look at this one. These are typical bases. LiOH, lithium hydroxide, sodium hydroxide, potassium hydroxide. Anything with an OH at the end. Remember, OH, hydroxide, is a polyion. It will be at the end of the formula. So hydrogen's in the front, it's an acid. Hydroxide's in the back, it's a base. Okay? There is one base that's fairly common, ammonia, who has a funky formula. There's no OH ions. He actually produces hydrogen ions, but they're all negative hydrogen ions, which considers him a base. So his formula is NH3. You will want to memorize his formula. NH3 is ammonia. Very important. Not ammonium. Ammonium is a polyatomic ion, and his formula is NH4. Right? This is ammonia, NH3. So you also need to know simple properties of acids. Think about acids, right? Like citric acid, orange juice, lemons, limes, tomatoes. They all have a sour taste. They're also corrosive. You could pour an acid on your face or your hand, and some of the acids will eat right through. You could pour a weak acid on your hand, and it'll burn a little bit. You could put a metal in acid, and in a few days, the metal will not be there anymore. The acid will eat right through it. So they're considered corrosive or toxic, right? They'll burn you. Bases are also corrosive, but they have totally different properties in terms of touch and feel and taste. They have a bitter taste. They're not sour. This is like antacids, right? Like kaopectate or Pepto-Bismol or Maalox. Any of those medicines that have a bitter, chalky taste when you drink them, it's because they're trying to neutralize the acid that's in your digestive system or acid reflux in your throat or, heartburn that you get. The base, all right, which are those medicines, are trying to neutralize the acids. That's what they do. Acids and bases can neutralize each other, right? Make each other neutral. So those are the properties of bases. They also feel slippery. These are like soaps, shampoos, lotions, detergents, bleach. These are all things that if you felt of them or got them on your skin, they're kind of slippery. So that kind of lets you know it's a base. All right, so let's talk about the pH scale. If I'm looking at the pH scale is actually a measure of how many hydrogen ions are in the solution. So the more hydrogen ions you have, the lower your pH value will be. So down here's, 1, 3, 4, 5, 6, 7. So the further you are to 0, the stronger you are. So these are your really strong acids. An example of a strong acid would be hydrochloric acid, sulfuric acid. Those are pretty strong, right? Digestive acid, stomach acid, gastric juices. Those are all pretty strong acids, okay? A weak acid would be something like coffee, milk. These would be your weak. Those are going to be your weak acids, okay? 7 is your only neutral point, right? It's dead in the middle. 7 is your neutral point. And the only neutral substance in the world is pure water, right? Pure, distilled, clean, no impurities, nothing mixed in it, just straight up good old clean H2O, right? So now we're into the bases area. So now we're talking about bases. And as you move through the scale, 8, 9, 10, 11, 12, 13, 14. 14 is as high as they go. Obviously, the closer you get to 14, the higher the number, the stronger your base becomes, right? So these bases down here, these would be like soaps, detergents, lotions, some foods, not many. Most of the foods are in the acidic environment. The bases are more like household cleaning products. And that's why cleaning products do what they do. That's why they're great at their job. Because even though they're bases, not acids, they're very good at eating through stuff. They're corrosive. Think about bleach. Bleach will burn holes through your clothes. Bleach will burn your skin if you get it on you and you don't wash it off. So your strong acids start at about 10 and a half. I'm sorry, strong bases. Let me back up. Strong bases start at about 10 and a half. So these are your strong your strong bases. Let me give you some examples. This is like oven cleaner, right? The stuff that eats all the crud out of your oven, that's got to be pretty corrosive or pretty strong. This is like bleach. This would be ammonia, right? Anything with a really strong, pungent odor in either direction, right? So down here, a strong acid I didn't mention would be like vinegar, right? That would be acetic acid, right? All of your medicinal bases, right? What I talked to you earlier about, the Maalox, the kaopectate, the Pepto-Bismol. Obviously, they're not strong bases or we couldn't drink them, right? You drink bleach, ammonia, or oven cleaner, you're gone. Toast. So all your medicinal bases are probably between 8 and 10, right? Right around here is probably where your medicinal stuff is, right? Over here, drink it, you die. Okay? So you have to have an understanding of the pH scale, be able to label it, answer questions about it in a multiple choice format for your end of course, right?